because that's the question that needs to be answered. Well, as you can see from a connection standpoint, all inter GPU communication never is technically local, right? It's technically local to the box from the box's perspective, from the GPU service perspective, because they're attached to every last one of the every switch, right? So it never actually has to go. Remember in the last picture, we had a problem with a lot of traffic here, right? So traffic rarely goes up to the spine. So traffic rarely, in this example, never goes to spine. Rarely slash never utilizes the spine, right? So that means you're not introducing a lot of latency in this design, which makes your operations technically your compute operates a lot faster because it never has to go to the spine, back to a leaf, and down. So you're not introducing those little latency, and in AI, latency is a big thing, right? Especially with RDMA, you don't want to drop packets and stuff like that, right? Because you can bring down the entire system. So in most CVDs or JVDs for Juniper folks, they're going to say, hey, use a rail optimized design. Because if I do have to go to, let's say, I use up all the GPUs in this box here, and I want to use this GPU here for more compute. Well, all I have to do, I go up to rail number one from a data plane perspective, and then I go right to GPU two. Now, remember in the other design, I had to go up to leaf one to spine one to leaf two to server. In this one, I go up to leaf or rail one and then directly to GPU. So I'm reducing the latency, which is increasing the performance of my AI cluster. So that is the difference between spine leaf architecture, normal spine and leaf architecture for AI GPU backend, and rail optimized architecture for GPU backend, right? Now, your storage backend and your front end could be just normal spine leaf, right? But in the AI GPU backend, which is your NVIDIA servers and stuff like that, or I think UCS does have its own version as well. But the GPU backend, you want to go with Rail Optimize if you can. All right. Because that's going to reduce the latency and increase the performance of your AI cluster. This is Don from Padlock Technologies again.